Hello, I'm Sumaya, and I'll be talking about the project that I'm doing for my C programming class. So, we have a project for which we have to do matrix addition, subtraction, transpose, and matrix multiplication, and then find in simultaneous linear equation from matrix. So, for today's project, we are gonna talk about like the matrix multiplication. So, I'll be talking about the part B first. So, in order to find the matrix multiplication, first I will declare the rows and columns as integer for matrix A and also the same for matrix B as well. And then I'm going to declare my result matrix that I'm going to find after multiplication multiplying both of the matrix. And then I'm going to ask the user to um, to declare the number of rows and columns for matrix A, and then I'm gonna ask the user to put the number of columns and rows for matrix B as well. So we know that for the matrix multiplication, row, the column of the first matrix should be equal to the row of the second matrix. That means, for example, here we have a 2 by 3 and 2 by 3 matrix, right? So this column of matrix A does not match the row of column 2. Sorry, so does not match the row of matrix 2. I mean matrix B. That's why we cannot do this matrix multiplication. In order to do a matrix multiplication, the the column of the matrix A should be equal to the row of the matrix B. See, in this case, it is 3 by 3. So that means we can do the matrix multiplication. All right. After checking if column A matches row B, we'll go to the next step, and then if it doesn't satisfy the requirement, then we will ask the user to put different values because that is not possible. And after that, I'm gonna ask the user to give values for matrix A and then for matrix B, and then you can see that I put a there is this calculation part that I showed here. So there will be integer result for every I that is equals to 0. I should be less than of row A, like the number of rows for matrix A. And then we are gonna increase the row by 1 each time. So let's say if we start from here, then the row will go till there's like 2 rows, right? The same for column as well. So for every row we'll have columns. So let's say if we're working with the first row, then we'll be working with the second column of the row and then third column of the row, and then again we'll just move to the next one, right? Okay. And then for every I that is less than row A, we'll get J that is less than column of B, and then the result initially we'll declare that as 0, and then we're gonna add it every time. So for every integer that is equals to 0 and I that is less than column of A, we're gonna increase that and then multiply matrix A times matrix B, right? So here we have if we want to show the matrix multiplication, it will be the first row, first column, plus first row, second column, and then that's how it will be going, right? So see the addition. So first row, first column, first row, second column. That's how we're gonna move on to the next one. Okay. So that was for my pseudocode, and then we're gonna print the result. Now we will have time. Then we are gonna talk about the AI generated part, that is the pseudocode for AI. if you see there, we can see that they also ask the user to give the values for number of rows and columns for matrix A and B, and then they declared the matrix, and then they just used the same method that I used for multiplying, but initially they declared it with an like a separate loop, but in my case I did it in one loop, right? Like this. So I think that is one of the differences that will be between my pseudocode and their pseudocode for the AI generated one. Okay. And then they just printed the result out. So the calculation part is same for both of our codes. And I think the major difference will be like mine is more logical. I mean, I worked more with the logic since this is a pseudocode. I didn't show exactly the codes, right? And mine is like easily understandable, like it's like a rough plan you can say before the actual coding. So I think I'll be using my method and take like, as I mentioned, for the I'll be using the user defined function, right? So I don't want to print like this again to ask them to declare the rows. So when I'll be doing sorry, so when I'll be doing my code, I'll just call the function two times, right? By using the user defined function. So that is my plan, and that's how I'm gonna do it. Now I'll be talking about part D. So if we go to the question, the part D is finding solutions of simultaneous linear equations with three metric unknown variables, right? So we're gonna take 3 by 3 for matrix A, and then 3 by 3 for matrix A, and then three constants for matrix B, right? So it should be something like this, right? 3 by 3, and then for matrix B we have this. Now if you go to my pseudocode here, we are trying to declare the matrix first, right? And then the float type, like if it's integer or float. So we are going to work with float since there might be a chance to have like decimal numbers. And then we also need to define the xyz variables as well. Then we will ask the input, like ask the user to input the coefficient elements of matrix A, the coefficient for x, y, z, and then we are gonna ask them to input the constant, put the value for matrix B, right? Now we have to find the determinant of the function. So in order, we'll be using Cramer's rule throughout the process. So how do we find the determinant function? I did not mention that in my code, but I'll just give you a rough idea about the code. Uh, so here, if this is a matrix A, and then if we're trying to find the determinant, then this first thing we could either work with a row or with a column, right? So if we are working with a row, then it will be like here one, and then we're gonna in the bracket we're gonna do 1 times 1 negative negative 3 times 3, that will be 1 plus 9, right? Times 1. Then we are gonna take the second one, and for the second one we'll take negative in front of it, right? So negative the second one, so this will be gone. Without this we are going to do the calculation, so that will be 2 times 1 negative 3 times 1, bracket closed, and then plus 1. So this thing will be gone, right? This L shaped. Okay, and then for that we will have 2 times negative 3, that will be negative 6, negative negative 1 times 1, so negative 1. That's how we are going to find the determinant for each of them, and then we are going to find a value for determinant of this A, right? Determinant of A. Now in order to find D of X, okay, I'll just mention one thing before going to that. So we know that for determinant of A, we need to have like determinant of A equals to something that should be not zero, right? So if it's equals to zero, then we'll just print that there is no unique solution. Otherwise we'll just move to the next one, right? And now you can see that I did the calculation for every integer that is I equals to 0, that will have I less than 3, right? And it will be increasing by 1 each time. And for every row, then we'll have like a column, right? For every integer j equals to 0, we will have that until like we reach to 3. So that will be equals to a1 equals to aij, right? Now if you move on, then we will see like we are just replacing the terms. So how do you find the determinant? We find the determinant, right? Then we are going to do d of x. And how do we find d of x? We are going to replace this with the first one, right? D of x, we just replace that with the first row, and then d of x. Yeah. So after replacing each of them, we are gonna calculate x equals to determinant of x over determinant of a, and that's how you find the values for x, y, z, right? Which will be our equation. I mean, which will be the value for our simultaneous equation, and then you're just gonna print the result of x, y, z. Okay. Now, if you talk about AI generated one, then they declared each of the A1, B1 first, right? Like A2, B2, C2. So that was the difference between their code and mine. I didn't do that. I just directly went to the see. I just directly went to these determinant ones. Okay. And then they asked the user to give the value for coefficients, which was the same for me as well. Then they did the determinant. So see, this is the formula that I was talking about. And they also mentioned the no unique solution one. Okay, and then for dx they just replaced it with like d of, like for d of x you're gonna replace the d of a with the specific columns or rows, and then you're gonna get the value for d of x, right? And then you calculate xyz, and that's how you just get the solution. So it's the same overall. And now for the comparison part, the logic is almost the same for both of the codes. Both of the codes declare the coefficients and constants, although for the AI part this was different for me, right? And the float, I didn't mention that. Since this is like a pseudocode, I thought like I don't have to actually show the calculation or like everything that I'll be doing for my code, but that I just gave a rough idea of how I'll be doing that. So now my code was just an outline, right? But the AI generated one is well structured and this is more professional. So they also mentioned the formula for determinant, which I did not, but I'll be using that for my main code. So for the project, I'll be using both of these codes, and like I'll be trying to implement like how I can just improve that. Since I'll be using the user defined function, I have to like just modify it according to that. And thank you so much for listening to me. All